Let's try another one. And we're going to use the log properties this time instead of doing it the stupid way. So we'll do number 13. I lied, it's too easy. We're going to do number 16. 16, yeah.
16.
I glanced wrongly at the one I meant to say. d dx of ln cos squared. Take the derivative of ln cos squared x. Okay, we have to analyze the, you guys got the log properties okay? I can erase them. You got it memorized already, probably. Just a quick reminder about them. Should be able to recite them like your name.
Why would you recite your name?
What's that?
Yeah, why?
What do you say?
Why would you recite your name?
Why would you recite your name?
Yeah.
So he says, what's your name? You can recite it for them. You can tell them what it is.
I say my name.
Aren't you supposed to say, hi, my name is Karen?
No, they say, what's your name?
Karen.
Alright. What's log property 1? See? Hey, you're not on the same level, right? Alright. So what is the domain? Domain of this expression. Domain of ln cos squared x. So you need to find out where cos squared is greater than 0. Right. Because that's what's being put into this thing. Cos squared is being put into this thing. So you got to make sure that it always evaluates to greater than 0. Trigonometric inequality. Blasted. Just quit now. Okay, first of all, it's cos squared. So a minute ago when it was x squared, what did you say? Everything except 0. So we should claim the same basic principle here. It should be everything except where cos equals 0, right?
So pi over 2 and 3 pi over 2.
Hold on, let me just make sure everybody agrees with that first though, right? As long as cos evaluates to something besides 0, negative or positive, and once I square it, it's going to be positive, and it'll be okay to put inside the log. So now I have to make sure that cos never becomes 0. So where does that happen? You were saying?
Pi over 2 and 3 pi over 2.
Those are the first 2 locations, if you're going counterclockwise from the initial side of your angle, those are the first 2 angles that make that happen, first 2 positive angles make that happen. So what is the, so pi on 2, 3 pi on 2, about negative pi on 2. Yeah, because it's the same location as 3 pi on 2, right? So you can go negatives as well. Right? And this just keeps on going forever. There's a lot of x values that aren't going to be allowed here, because cos evaluates to 0 infinitely many times, right? Cos and sine must have an infinite number of zeros, so does tan. The other one's cotan as well. So, what's the formula you want to write? X, this is what they're looking for. X cannot be what? No, x can be 0.
2n plus 1.
What did you say?
2n plus 1 pi over 2.
2n plus 1 over 2
Pi
times pi. What are you saying? Is that what you said?
Yeah.
How do we get that?
I don't know. Talk to Lee. He said it. What can n be, Lee? What kind of number is n going to be?
And the 0, 1, 2, 1, then equal 1.
What kind of numbers are those?
Real numbers.
Nope. Integers. It's going to be an integer. Okay? If n is 0, which is an integer, then this will read a half pi. Bad, right? We're trying to get rid of that one. If n is 1, that's an integer. So it's going to read 3 on 2 pi. Bad. We're getting rid of him, right? So this describes all the bad locations, right? These are all the bad x's.
That have to be plus or minus.
N being an integer takes care of that, because if n is negative 1, right? I'll get negative 2 plus 1 is negative 1, negative 1 half pi. There he is right there, and so too for all of them. This takes care of every single problem spot, right? So how do you write this? Domain of this thing is, you do not want to use interval notation. It is all reals except for, now you must use this notation. Any x such that x equals that expression. 2n plus 1 on 2 pi. As didn't expect it to get this technical, did you? Right. I guess I really have to say n is an integer. Without using the fancy pants notation. Right? That describes the things you need to take out of the real number system. And everything else is just fine. Now let's take its derivative. Alright. So, what's the derivative of natural log?
1 is the reciprocal of what's inside.
That's right.
So one
The
over
reciprocal of what's inside. So 1 over
cosine squared x.
1 over cos squared. What is another way to talk about 1 over cos squared? Reciprocal trig functions. Secant squared. Secant squared. Right? So I'll write 1 over cos squared first, though, just so it stays with our basic formula. 1 over cos squared times derivative of cos squared. So that's the same as saying secant squared, meaning for the first part, times the derivative of cos squared. Now that's a chain rule, right? You got to bring down the 2. So times 2, keep the inner function the same, and now multiply by the inner function. Right? Now you just clean it up a little bit. You call it, now cos, what's cos times a secant? A single secant times a single cos is what? Cancel it out because it's 1, right? So we can get rid of this cos and one of the secants. So we're left with negative 2 sine secant.
Wait, I
Oh,
have
wait
a
a
question.
second. Secant's 1 over cos, so sine times secant must be, right. So we can write this as negative 2 tan. All right, go ahead. You were saying, Cornejo.
Why can you cancel out the cos and the secant?
Because secant is 1 over cos. So if you have 1 over cos times cos, you get 1. Negative 2 tan. Okay. You guys okay with that? That derivative? Carter? You seem hesitant.
That graph would just look like tan. You see what I
I mean,
mean?
just look like
Would
it's
have
like.
Yeah, the graph of the derivative, right,
Yeah, the graph
is just
And you're adding
tan
to it.
lines.
reflected about the x-axis
They would have asymptotes at those.
at these locations.
Yeah. Or would they have the asymptotes at regular tan locations?
They're the same thing.
Oh, they're both, okay.
Yeah, because remember what we excluded here. We excluded here where cos was 0,
Oh.
but what's tan? Sine on cos.
Oh, yeah, so it's undefined.
So, right, wherever cos is 0 are the asymptotes for tan. So it ends up being the same thing in this case. Carter, you gonna say something?
No, I was looking at the beginning again. I forgot. You have to take the derivative of the inside. Which rule is that when you take the reciprocal with the derivative?
The reciprocal itself is just the natural log derivative.
Right.
But to do the inside is to finish off the chain rule. We always use the chain rule. Yep. And the book actually writes it, the chain rule for log, just so I don't know if it makes it easier to think about it or not, but I'll write it here. If you have ln of u, then it's u prime over u. That's always